Good afternoon, everyone, and welcome to another exciting day in mathematics. Whoop, whoop. And no green screen today. I had some. I need to catch up with some of the technology piece, and I'm still trying to put a couple things together. But without further ado, let's get started. Our warm up for today is warm up 123, Michael Jordan, and it reads: number one, graph the circle x squared plus y squared plus 6x minus 4y plus 9 equals 0. Number 2, compute the sum, difference, product, and quotient of x minus 3 and x minus 3. Number 3, factor by grouping, and we got 2x squared plus 11x plus 12. And number 4, graph f of x equals x cubed, but then graph the transformation given by g of x. And g of x given is g of x equals f of parentheses x minus 4 close parentheses plus 5. All right, that's warm up 123. Pause the video, and if you need to look at the processes, it's the same one that we did on Tuesday. So just go to that video so you can see it, or look at your notes. All right, pause it, and then we'll come back and continue. All right. So we should be back. Our home plate for today is on page 790, all only. 790, all only. All right, and no Nearpod code today. Just work on those. On next week, I'll give you, for the next video, I'll give you the Nearpod for both the lesson for next week and for this one. So make sure you work these out. Let's move on. So our objective for today: I can simplify logarithmic functions. I can simplify logarithmic functions. And we're still on the same concept, if you notice, logarithmic functions. And once again, I'm trying to get you guys, we're scaffolding this, tic-tac-toeing it so we can build up. So we already have two properties that we covered the other day on Tuesday. But before that, we know what logarithmic functions are. You should be able to fill this out by yourself again. Yes, again. And then we covered the basic logarithm and all its parts. Yes. All right. And then from there we went to some definitions. And what were the definitions? Just to recap, we said that whenever you have a log that has the same base and the same given number, that means that the answer for this one would be the exponent on the given number. Or I did y equals m. Right? So let me show you the work that I did. There it is. So what do you guys notice? Log, same base, same given number. So the answer here would be 4. So in short, check this out. If you wanted to not do all this work, but you actually identified that the base is the same as the given number, you can go straight from here to here. And today I'm going to have you guys remember that, because we need to know all this, because we're going to get to some problems where they include almost all the properties in one problem. Let's go. All right, so look at this one, log 2 and given number 2. So what did we say on this one? When the base is the same as the given number and the given number does not have an exponent, the answer is 1. That is correct. So could you go from here to here? Yeah. And that's something that we need to keep in mind. And the last one, log to whatever base, if the given number is 1, the answer is always 0. All right? Quick recap, yeah? All right. So from there we got into the product property of logs. And what did this do when we're multiplying? What does it imply? That we add log b of m and log b of n. And then we did a sample problem, and I gave you something like this. And what did we do? Same base, so we wrote it as log 3, and then this one is 3 times 81. There it is. 3 times 81 is 243. And then we need to find out if we can write this one using the same base, and we were able to, which is 3 to the 5th. There it is. So that means the answer is 5, because now we have the same base as a given number. All right, so from there we got to quotient property of logarithms. And if we added for the product property, what do we do with quotients? We subtract. That is correct. Log b of m minus log b of n. And a sample problem, I mean, I gave you a couple, but the sample problem that I'm going to use is the first one I gave you that looked like this. So log 2 of 8 minus log 2 of 32. Since they're the same base, I write log 2, and it's 8 divided by 32. And I said, can we simplify this to lowest terms? Yeah, it becomes 1/4. Can we write the 4 on the same base as 2? Yes, this becomes 2 to the second, but it needs to go in the numerator, so it's 2 to the negative 2, so y equals negative 2. All right, which brings us to this property. So write this down, power property of logarithms. Log b, and then the given number is m to the nth power. You're like, oh snap, I know. So if you notice now, the base is not the same as the given number. They're two different numbers. What does that mean? That it cannot be written on the same base. Same base. If we give you a number, it cannot be written with the same base. So what do you do with the exponent? Whenever it's a power property of logarithms, you write it as follows. N will be a factor in front of the entire log b of m. So what is the only thing that we did? We moved the exponent of the given number. We move the exponent of the given number to the front to be a factor, or that it's going to multiply whatever we have here. And that's how we end up with this. You guys see it? Copy that. All right. Pause it if you need to, so you can finish taking notes, but let's move on. Example 3. So it says, express each expression as a single logarithm and simplify if possible. So let's look at this, and I left the power property of logarithms here. So what do we know? Are these the same base? No. So at this time I'm going to move the exponent of the given number as a factor of the whole log. So I'm going to move this one. I'm going to move this to the front, so this becomes 3 times what? Log 4 64, and that's it. So now let's focus here. Now, can we write 64 using the same base? What is a base right now? 4. Can you write 64 with base 4? All right, let's find out. 64 divided by 4 is, 16, okay. And 16 divided by 4 is 4. So this became what? 4 to the third. And right now I'm only working on 64. You guys notice that, yeah? Okay, so let me rewrite the whole thing just to see if you see what I see. 3, what didn't we mess around with? The log 4. And 64 became what? 64 became 4 to the third power. And you're like, oh, I remember this, Mr. Q. If the base is the same as the what? Given number, the answer is what? The exponent of the given number. So therefore, the answer for this piece is 3, because it's the same base and the same given number. The answer is 3. All right, are we done? No, we have this factor. So I'm going to multiply that times that. So now our answer is 9. Bam, let's go. Now, some of you are probably thinking, Mr. Q, do we need to show you work for this? No. I mean, once you identify the definition, remember I asked you to write that in a index card. If you haven't, write it in an index card so you can memorize it and keep it in mind, because you're going to need this. We're going to be using these a lot, okay? So once again, you don't have to show me work as long as you identify the definition. You give me the answer for that piece, and then this, and so on and so forth. Copy that. If you need to pause the video, pause it. All right. All right, and we're back. So let's do another one. This was example 3. Let's go to example 3Q. Example 3Q, same thing. Express each expression as a single logarithm and simplify if possible. We got log 3, 81 to the 5th power. So let's do this one together. Copy that. You don't need to copy the instructions anymore. Just copy the log. All right. So what kind of property are we working with right now so far? It's the power property of logarithms. What do you notice? That the 3 and the 81 are not the same. The base is not the same as the given number. So what am I going to do with this exponent of the given number? It goes where? In the front. So that is 5 times log 3. And then I write 81. And that's it. Okay. However, question, can I write 81 in base 3? You're like, let's try, Mr. Q. All right, so then right now we're focusing just on the number 81 of the given number. So 81 divided by 3. Yeah, 3 fits into 8 twice. We have 2 left over. 3 fits into 21. Oh, hold on, let me move this because it looks like a 4. There it is. 3 fits into 21 7 times. Okay. How about 3 again? 3 into 27 is 9. And 3 into 9 is 3 times 3. So how can we write 81? 81 is written as 3 to the 4th power. Alright, let's write the whole thing and see what it looks like again. We got 5. That's multiplying what? Log 3, and 81 became what? 81 became 3 to the 4th power. Alright, do you see, can you identify the definition here? Yeah, the definition of if we have the same base, the same as the given number, the answer for this is what? What is the answer for this piece? Yeah, it's 4. Are we done? No, we need to multiply now times 5. So the answer for this is 20. Copy that. Hopefully you got that one by yourself. Pause the video if you need to. Now let's do another one. See if you can do one by yourself. Example 3 Super Q. Let's see. Example 3 Super Q, same instructions, and it reads log 2, 64 to the 6th power. Pause the video and see if you can do that one by yourself. Alright, now that we're back, let's see. Once again, it's a power property of logarithms. So what do we notice? That on the given number, we're going to put the exponent as a factor over here in the front. So that's 6 times log 2 and the given number 64. Question, can we write 64 to base 2? Let's find out. 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. So 64 can be written as 1, 2, 3, 4, 5, 6. 2 to the 6th power. Alright, let's write the whole thing. So we have the factor of 6 times log 2. And 64 became what? 2 to the 6th power. Okay, so let's focus here. What do you guys notice? The base is the same as the given number. So therefore, what is the answer for this piece? That's right, it's 6. Are we done? No, we need to multiply times the factor, which is 6. So the answer for this is 36. Bam, let's go. You got it? Alright, I think we got this, right? Yes, Mr. Q. Alright, good. Alright, one last one. Copy this one, example 3 mega Q. We got log 6, and we got 36 to the 7th power. Pause the video, see if you can do that one by yourself. Alright, let's see how you did. So, power property of logarithms. So what happens to this exponent? We send it as a factor. So that's 7 times log 6 and with the given number 36. So question, can we write 36 to the base 6? Yeah, 6 times 6. All right, so that means this is what? 6 to the second power. So let's rewrite the whole thing. So we got 7 as our factor. Then we got log 6. And what was 36? 36 became 6 to the second. All right, so let's simplify this piece. Do we have the base the same as the given number? Yeah, so the answer here is what? 2. And then lastly, we multiply times 7. So the answer is 14. Let's go. You got that? Yeah? Yeah. Yeah, it's just a matter of getting used to not, because I know in the previous, when we first started with properties definition, I wanted you to show me all the work and stuff. But now that we're going to get into more complex logs or using the different properties, it requires more steps. So I'm going to have you do just definitions. And if you remember the definition, then just do that. Now some of you are like, Mr. Q, what if we don't remember the definition? Then I want you to work this one out on the side and showing me all the work. Y equals log 6, 36, base 6 to the y equals 36, change each space the same way, and so on and so forth. All right, let's move on. So that was power properties of logarithms. Well, now we get to the last property. The last property is change of base property of logarithms, and it reads log base c and the given number a. So what does that mean, Mr. Q? That the base is totally different from the given number, and it cannot be reduced or it cannot be rewritten with the same base. That's why they have two totally different values. So that means that this becomes log base b given number a and log base b given number c. So what do you guys notice? That the numerator basically stays the same as this, and we just change the base from c to b. But the denominator, we take c as the given number, and we change this to log b, the same as the top. All right, let's see how that works. Copy this one. Example 4, and I'm going to leave the property over here, change of base property of logarithms. And it says, example 4, express each expression as a single logarithm and simplify if possible. Log 2, 3. You're like, okay. Copy that. So we have log base 2 given number 3. So let's do this one. We can do this one together. Here we go. So what do you guys notice? Do you see that we have the base and the given number? They're totally different numbers. Number 1. Number 2, can we rewrite 3 in base 2? No, because it's a prime number. We can't simplify it any other than that. So what do we do, Mr. Q? Then we rewrite it. So this becomes log 3 over log 2. You're like, what? Yeah, so look at this. Log given number a, there it is. Log given number c. Log given number a, which is 3, and log given number b, which is 2. So some of you are like, so what's the base here, Mr. Q? Well, if it's invisible, what's the base? Yeah, an invisible 10, remember that? Yeah, but for right now, we're up to right there. So far, so good? Okay. So once you get to that point, the next part is going to be a piece of cake, because all we need is a calculator. All right? So check this out. So once you get to this piece and you cannot simplify anymore, then I want you to go to Desmos.com, or if you have a scientific calculator, check this out. In Desmos.com, they do have a scientific calculator down here. You guys see it? All right, so you're going to click on it. All right, so the first part was, the numerator was what? Log 3. So here you're going to go where it says function. And then you're going to go log. Type in 3. And that is 0.477 approximately. 0.477. So I'm going to go back to where was I? Right here. So what was it? This was approximately 0.477. Let's see. Yeah. So then now I'm going to type in log 2. And we got 0.301, 0.301. So I'm going to go to and then we have this over 0.301. Oh. So, and what does this give us? Well, let's type this in. Let's see. I'm going to do, it was log 3 divided by log 2, and that gives us 1.584. 1.584. All right, approximately 1.584. We're like, what? Yeah, that's simple. All right, copy that, pause it if you need to. All right, let's go to example 4Q. See if you can try one by yourself. Example 4Q. Same instruction, and it says log 5 given number 7. All right, pause the video. I'll give you a little bit more time. All right, now that we're back, let's see. So once again, change of base property. Now, can the 7 be, what was the base here? 5. Can the 7 be written in base 5? No, because 7 is also a prime number. So how do we write this? This becomes log 7 over log 5. All right, so let's go to our Desmos. Log 7, that's 0.845, 0.845 over log 5, 0.69869. I want to do 699, and I'll leave it at 699. 0.699, and this is approximately, let's see, log 7 divided by log 5, and that's approximately 1.209. 1.209. 1.209. Once again, put the wiggles, it's approximately. All right, and that's basically it for the change of base property. And those were the last two properties that I needed to introduce. So let's recap what we've seen so far. We've seen definitions. We've seen the first two properties that we did the other day, the product property, the quotient property. And today we covered the power property and the change of base property. So once again, if you don't have those written down, pause the video right now, write these down and keep them handy because you're going to need them, because right now we're going to get a funner one. We're going to crank it up a notch. So once again, recap, log b to the m. What does this definition tell us? That if the base is the same as the given number and the given number has an exponent, the answer is the exponent on the given number. So the answer is m. For this one, if the base is the same as the given number and the given number does not have an exponent, the answer is 1. This one, if the base I'm sorry, if the given number is 1, doesn't matter what the log that they're asking you to get, the answer is always 0. Those are something that you need to remember, okay? And you need to have them handy. Like I said, we're going to get into some more that are funner, and you need to know all these. You need to remember the properties, what they do, the product property of logs, quotient property of logs, power property of logs, and the change of base property of logs. So now I'm going to start combining stuff. I'm going to combine maybe this definition with a quotient, and then the change of base, or maybe this definition with the product property and power property of logarithms all together in one. Y'all ready? Let's go. 23 from the corner. Bam, let's go. All right, let's copy this one. Example 5 super Q. And yeah, and I'm starting with super Q now because it's nice. And it reads, express each expression as a single logarithm and simplify if possible. And the given logarithm is log base 8 given number 18 minus log base 8 given number 2. All right, copy that. If you need to pause it, pause it. All right, now that we're back, let's see. What do we got? If it's subtraction, what is this implying? Yeah, this is the quotient property of logs. All right, but before anything, I said to keep all the stuff handy on an index card or something. So I'm going to put it over here on this side, what we've seen so far in regards to definitions and properties of logs. I'm going to leave it there for right now. So let's focus on this. This we said is the quotient property. Okay, so we can rewrite this as, let's see, log 8, because they both have the same base. And we get what? 18 divided by 2. Okay, next. Log base 8. What is 18 divided by 2? 9. Okay, question. Is the given number the same base as this one of the base? No. Can we write 9 as base 8? No. So if they are totally different, which one of those can I continue with? Yeah, the power property of logarithms. Oh no, not that one. What do we do at the end? The change of base property. Yeah, they're totally different. This one's totally different of that one, so it's a change of base property. So what do? This becomes log 9 divided by log 8. And now we just go to decimals and see what we get for that. Let's see. So we got log 9. Log 9. That one is 0.954. Okay, 0.954. 0.954 over log 8. 0.903, 0.903, and this is approximately, let's see, log 9 divided by log 8, and that gives me 1.057. 1.057. 1.057. So what do we notice? That here they combine what? They combined, first of all, the quotient property of logarithms, and what else? When we got to this point, since these are totally different, they cannot be written the same base, we need to use a change of base property so that we can simplify to lowest terms. Copy that. Pause the video if you need to. All right. Let's do another one. So do you guys see how now they're combining the different properties into one problem? Yeah, so you just need to remember and go through your scanning through the definitions and the properties. That's why I have those handy, or maybe you already memorized them. Bam, let's go. All right, example 5 mega Q. And it reads, express each expression as a single logarithm and simplify if possible. And they give us log parentheses, check this out, log base 3 given number 162 minus log base 3 given number 2, close parentheses, to the x power. You're like, oh snap, I know, right? So let's have those properties and definitions handy. Let's do this one together. Here we go. I'm going to start with the colored blue. So if you notice, there's a log raised, this is the given number, and over here we have an x as an exponent. So right now I'm going to focus inside. What do you guys notice in here? Do they have the same base? Yes. And this is what? Subtraction. So what are they implying? That this is the quotient property. So how do I rewrite this? This is log 3, and we have 162 divided by 2. So this becomes, let's see, 162 divided by 2. This is log 3, 81. Okay, so question. These are not the same. The base and that number is not the same. But can we write 81 in base 3? Let's find out. 81 divided by 3, that's 27. 27 divided by 3, that's 9. 9 divided by 3 is 3 and 3. So this can be written as 3 to the 4th power. Alright, so I'm going to rewrite this. I'm going this way. So I write log 3, and 81 became what? 3 to the 4th power. Alright, do you recognize anything up to right there? Yes, the definition. If the base is the same as the given number, which is this one, what is the answer? That is correct. The answer is 4. Whew. Alright, so basically all of this inside of the parentheses became what? 4. So I'm going to bring down the parentheses, the exponent, and I'm going to bring log, and that's it. Alright, are we there so far? Okay, so what do we notice here? Does this have a base? You're like, no. Well, yeah, invisible, it's a what? Yeah, that is correct. It's a 10. Alright, but what do you notice here? That this has an exponent. And what do we do when this has an exponent? That is correct. Now we're going to use the power property of logs, which means I'm going to bring this x and I'm going to bring it over here. So I'm going to rewrite this. This becomes 4 log 4. Oh, my bad. It's not 4. It's x. Sorry. X log 4. Some of you are like, Mr. Q, it's x. I know. I heard some of you. Alright, so x goes in the in our factor, and then we got log 4. Alright, so when we get to this part, if you don't want to do all the work, can we find log 4 using the calculator? Yeah, let's find out. What is log 4? Log 4 is 0.602. 0.602. So we end up with, let's see, this piece right here is going to be 0.602, but then we need to multiply times what? X. Alright, so how do we write this? Remember, the variable, whenever we're multiplying numbers, the variable goes at the end. So this is 0.602x, approximately. Alright. Lock your, pause the video if you need to. Copy that, please. So, like I said, as we continue on, it's just going to be adding more steps and, a couple more things to each, but take it one at a time. Alright, we're back. So that was example 5 mega Q. Let's crank it up a notch, yeah? Example 5 super duper Q. Let's go. And it reads, same instructions. We have log base 3 and given number 3 to the exponent of x plus 2 plus log base 2 given number 16 to the third power. All right. Once again, I'm going to have my index card handy over here with all the properties and definitions. All right, so let's do this one together. Let's take it by parts. First of all, we have plus, which means it's implying what? Product property. However, that only works, look at this, if they both have the same base. Do both these have the same base? No. Okay. So that means I'm going to focus right now here. Let's see. I'm going to use blue. Circle this piece. Just look at that piece. Look at it. And does that look familiar? Yeah. Which one of those does it identify with? Well, the base is the same as the what? The given number. That is correct. So if the base is the same as the given number, so what is the answer for this if I was to ask you to write something? Yeah, x plus 2. So that means if these are the same, the answer is x plus 2. We're done simplifying that piece. All right, bring down the plus. All right, now I'm going to focus here. Okay, I'm going to use red. What do you guys notice? We have a base, which is not the same as the given number, but the given number has an exponent. So what property can we use for this? That is correct, the power property. So that means I'm going to take the 3. That's going to become our what? Our factor. That goes 3. Then we have log 2 and 16. So here goes a question. Can you write 16 in base 2? Yeah. Let's see. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So we have this. It's 4 times. And this is 2 to the 4. So let me rewrite this whole thing again. This is 3 times log base 2. And 16 became 2 to the 4th power. Question. Let's see. Do you recognize anything here? Yeah, definition. Base is the same as the given number, so what is the answer for this piece? 4. That is correct. Then we need to multiply times what? 3. So what is 3 times 4? 12. Alright, so basically we simplify all this second part right here. So what do we need to bring down? We need to bring down the plus, and then we need to bring down the first part, which was what? X plus 2. Alright, so what do we have left? X, and what is 2 plus 12? 14. Bam, let's go. Now, do we need to solve for anything there? No, we're simplifying. That means these are still expressions. Yes, we're focusing on functions, but right now we're focusing on simplification only. All right, so copy that, please. You're like, man, Mr. Kids had a lot of pieces in it. I know, but it's still doable. Like I said, you need to know all the components. All right, let's go to the last piece. Pause the video if you need to copy that. And the last one for today. Ready to crank it up a notch? Bam, let's go. 5MJQ. Michael Jordan from the corner. All right. It reads log base x plus 3. And the given number is x squared plus 6x plus 9. And all that to the 4th power. Okay, once again, I'm going to have my index card over here with this. So, first of all, does that look familiar or anything like that? Let's see. The base is a base the same as the given number. Bless you. No, right? But what do you notice the given number has? An exponent. Oh, so which one can we use? Yeah, the power property of logs. So what happens to the exponent on the given number? It goes in the the front. So this becomes 4. And then we have log. The base is x plus 3. And the given number is x squared plus 6x plus 9. All right, question. Can we write this number using the same base? What is the base? X plus 3. So question is, can we have factors of x plus 3? Let's find out. Can we factor this to have x plus 3? Let's see. X plus 3 times what gives me x squared plus 6x plus 9? Let's find out. 9 goes up here. 6 goes down here. Factors of 9 that add up to 6. 3 and 3, that is correct. So this one is right here, x plus 3. So what is my second factor? X plus 3. So how do I write this now that I have x plus 3 and x plus 3? That is correct. We have x plus 3 squared. Let me bring the rest of it down. 4 times log. Then we have the base x plus 3. All right. So let's find out. What do we notice, or what can we use now? Oh, sorry. Is the base the same as a given number now? Yeah. So what do we know? That this is our definition. If the base is the same as the given number, what is the answer? That is correct. The answer is 2. And what do we do at the end? Multiply times 4. Therefore, this is 8. Copy that. Let's go. Yeah, I know, right? It's fairly simple, but it just has a lot of components. All right, guys. So, once again, our home plate for today is on page 790, all only. Once again, make sure you practice. I gave you plenty of exercises that look like the ones from the home plate, so hopefully you can finish and follow along, and then we'll pick up the home plate towards the end. And remember, if you're not moving forward, you're already behind. Don't forget to use Desmos, all right? Okay, guys. Love you guys. See you guys next week. All right? Peace.